In lesson 56, we're going to be talking more about circles and different angles related to the circle. You've already learned about central and inscribed angles. You've already learned about circles that have an inscribed quadrilateral and special properties for the angles then. Today we're going to talk about angles with circles that look something kind of like these two pictures. And we will come up with some formulas that let us figure out how big the angles and the arcs may be. First, reviewing a little bit of vocabulary and doing a little bit of new vocabulary. You already know central angles, and in order for something to be a central angle, the vertex must be at the center of the circle. And you must absolutely know that that is true. Just because it looks close to the center doesn't necessarily mean it is. It might be off just a little bit. They either need to put a dot in there or tell you that it's a central angle or something that lets you know that for sure. With or without an angle in there, and I really don't even need that in there, I can talk about parts of a circle. A minor arc will always be less than 180. It is the shortest distance between 2 points that are on the circle. So on this picture, my minor arc would be that section right there, less than 180 degrees. But on some problems, I might want to talk about the long way around between A and C. So I might want to be talking about this other one if I went all the way from A around to C like that. If I want to talk about something more than 180 degrees, I will need to use 3 letters to name it. Start at A, go through B, and end up at C. Or start at C, go through B, and end up at A does the same thing. So minor and major, smaller and bigger. Do you go the short way or the long way between the points? And it does not have to have an angle in there. It could, but it doesn't have to. It's just about the points that are on the circle. For the pictures that I gave you at the beginning, we had some lines going through circles, and they were intercepting different arcs of different sizes in there. And let's talk about some of the different kinds of lines that we could have. We could have something that goes through a circle and intersects it at 2 points. When that is true, we call it a secant. Technically, a secant is a line, so it is going forever in both directions. Oftentimes, we want to talk about just the part of that secant line that is inside the circle. And so that would be what we call a chord, spelled with an H, just like a musical chord. And that just means it has endpoints that are on the circle. A diameter is just a special chord because the diameter has 2 endpoints on the circle, and it happens to go right through the middle of the circle. Most chords do not go through the center of the circle, so most chords are not diameters. So far, so good with that. The other kind of line that we'll talk about with a circle is one that just touches the circle once. It only intersects 1 point, and in that case, we say that it is a tangent. It could be a tangent line, a tangent ray, a tangent line segment, but it just touches that circle once. And then there's a fun, helpful, useful property about tangent lines. If you draw the radius between that point of tangency and the center, it will always be perpendicular. And I put up the reminder that perpendicular just means they make that 90-degree angle. If we go back then and look at the pictures on that first slide, you see in this first picture, I have two chords that cross. And in the second one, they don't really go forever, but I could draw them out so that they keep on going. Don't need, I could have that or not. So that's part, I originally had part of some secant lines that crossed. So you see why we needed these definitions of chords and secants, and we're going to talk about where they cross. So where do the chords cross, inside or outside the circle? Inside. That's going to be a key for our first formula. If you have two lines that cross inside the circle, then what is going to happen is you are going to have these two arcs, and these two angles are going to be congruent to each other because they're vertical. But you see how for the angle X, those intersect A and B. Now, yes, I could also talk about these angles here and have a similar formula, but they'd have to use these other two parts of the arcs that I did not shade in the beginning. So once we pick an angle, we're talking about the arcs that those angles catch, that they intercept on the circle. Do not try to memorize these formulas with these letters. Instead, memorize it X, and if I come over here and look at my picture, X was my angle. So I want you to memorize this as the angle equals, A and B are both arcs, right? So memorize this as the angle equals the arc plus the arc over 2. If you try to memorize it with X equals, you're going to get yourself messed up because sometimes I might tell you the degrees for the angle, and I might tell you one of the arcs, and I might want you finding the other arc, and I might put an X over there where this one has B. I could use any letters I want to on a problem, and if you memorize it as X equals and I put X in a different place on a problem, you're going to mess yourself up. So you'll be better off memorize this as angle equals arc plus arc over 2. And that's what we're going to write down first when we do any of these problems. This is what is true anytime the lines intersect inside the circle. So far, so good. Okay, so then got 3 other possible pictures here. Where do those lines cross? What about this one? The good news is if the lines cross outside the circle, doesn't matter which of those 3 pictures, the formula is going to be the same. It's a little bit different than if they cross inside the circle. In this case, the angle is arc minus arc over 2. So that's the only difference. Inside it's a plus, outside it's a minus. Because we want this angle to be some positive answer, it doesn't make sense to say I measure that and get a negative angle. I always need to do the bigger arc minus the smaller one. The one that's farther away minus the one that's closer, so that my angle can be positive. And for my 2 other pictures, if now I have just one of them as a tangent, they still cross outside. And I have that the angle is arc minus arc over 2. If we looked at the 2 arcs, they happen to be adjacent to each other. They touch at that one point where that one line was tangent. If they are both tangents, it is still the same formula. Angle is arc minus arc over 2. But notice what happens this time. If I find my 2 points of tangency, and if I talk about one arc, the one that's farther away, that's bigger, minus the closer one, what happens if I put those arcs together? when they're both tangent lines. I get the full circle. They'd add up to 360 degrees. Question? I will in a moment. Questions on what I've talked about? Okay, we are then ready to do some example problems. So in this picture, do the lines cross inside or outside the circle? So is this the plus or minus formula? And I want you to write down angle equals arc plus arc over 2, and then show me your substitutions. So on this one, x is the angle, so I put the x here where the angle is. For the x, the two arcs are 80 and 60. And everybody shout out, what does that mean x equals? 70. It already has a degree sign in that picture, so I don't have to write the degree sign down. Thumbs up, thumbs down on that example. Once you've got the formula down, these are easy. I think they're fun because they are that straightforward. Okay, do these cross inside or outside? So is this the formula with the plus or the minus? So we start by writing down angle equals arc minus arc over 2. X is the angle, so we put that where we just put the angle. Do I want to do 20 minus 70 or 70 minus 20 when I subtract the arcs? Because I want it to end up being positive. So 70 minus 20 over 2 is how much, everybody? Thumbs up, thumbs down for that one. Okay, next one. Do they cross inside or outside? Outside. So is this a plus or minus formula? So for this one, I'm going to write down that the angle is arc minus arc over 2. What is the angle labeled with? So I put an X in for the angle. The arc that's far away is 280, but I'm in trouble. I don't think I have enough information to figure this out. Or do I? Pascal. So if I look at this, there's my 280. The other one that I need is this. So everybody, how big is that going to be? So that one does indeed need to be 80. So now I can put my 80 in here. And what do I have? I have 200 over 2. So X needs to be 100. And one last one, and then you guys got to do some on the whiteboards. Cross inside or outside? So formula has a plus or a minus. So we start out by writing down angle equals arc plus arc over 2. So do I say X is 30 plus 80 over 2? And I'm modeling that because that's what I see students do incorrectly all the time. What's wrong with this? Kaylee? Yeah, the angle is not X. So I can't put an X there where the angle goes. To do this one correctly, I need to say, oh, the angle is 80, so I have to put an 80 where the angle goes. The arcs are X and 30. It doesn't matter which one I do first. Now, how do I solve that to get what X has to be? Cooper? I could do that. I could say that 80 is X over 2 plus 30 over 2, but I don't want to do it that way. What's another idea, Melissa? That's not going to really help me because then I'm going to have 2x plus 60 over 4. And so that's going to be kind of confusing. Elizabeth? So I could multiply both sides by 2 to clear the fraction, and I'd have 160 is x plus 30. Or if you prefer, I could think of that as 80 over 1 and do the cross product. And then I would have 160 as x plus 30. So everybody, what's x? Any questions on what we've covered today? Then grab those whiteboards. I want you guys to give me some quick practice here.